let's learn about how to solve an equation on the calculator, on the graph. Okay, but first we need an equation. How about this one right here? Okay. So this equation is what we want to solve, and like we've seen in other videos, this means x squared. I'm just not able to really write it when I type, but yeah, it does mean x squared. Okay, so how are we going to do it? Okay, well, you go to y equals, and the left side of the equation, there's the x right next to the green button. The left side of the equation, plug it in for y1, and the right side of the equation, plug it in for y2, or vice versa. It doesn't matter. I just always do it the same way. Okay, now we are ready to go to the graph. So let's see what our graph looks like. Okay, cool. Now that's probably not what yours looks like. My viewing window is a little bit peculiar. However, I'm looking for the intersection point. Okay, now if I go to the standard viewing window, zoom 6, I'll still see it. But, oh, look at this. There's an intersection point there, and there's one there. Now, every intersection point that you see represents a solution to the equation. Since the highest power of the variable is 2, that means that there should be 2 solutions. Okay, so we gotta get both. So let's go second trace, and then option 5 is the intersection point. So 5, and then there's some questions here. What is your first curve? Yep, the blue line is my first curve, y1. Okay, what's your second curve? The red one? Yep, y2. Give me a best guess. I'm just gonna hit enter. So basically you just go second, trace, option 5, and then enter, 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 3 enters. So one solution is negative 1.236068, or negative 1.24 or something. That's one solution. What about the other solution over here? Well, if I just go second, trace, 5, 3 enters, it homes in on this one because the cursor is closer to this intersection point than that one. And it always just homes in on whichever one's closer. Now, here's a mistake a lot of people make. They'll say, all right, well, if that's the case, I'll just move the cursor over right now, get it closer to the other intersection point. It doesn't have to be on it, just whatever it's closer to. I did say this is a mistake most people make. Okay, so I think we can all agree that the cursor is now closer to this intersection point than this one. But when I go second, trace, 5, enter, 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 I still go here because did you notice as soon as I did second, trace, 5, the cursor zoom, jumped over to here. So if you want the cursor over there, you have to go second, trace, 5, and then you can do it right now, or you can hit a couple of enters, and then when it says, what's your best guess? Okay, use the left and right arrows to get closer to it. Okay, that's plenty close. And now it homes right in on it. And because it says intersection, I know that the process is done, and there's another solution, 3.236. I'm not using the y value for this. There are times when you will use the y value for different things, but not this. Okay, when you're just solving a regular old American loving equation, you don't use the y value, the y coordinate of the intersection point. So that's the idea. Okay, so let's try one more. All right, so here's a new equation we've got right here. Obviously, we could solve this one by hand, no problem. But let's practice. Okay, so we've got 12 plus 1/2 x and negative 7 minus 3/5 x, or 0.6x. Okay, now when I go to the graph, look what happens. Well, do I see the intersection point? No, not yet. Do they intersect? It sure looks like it. I mean, somewhere, about here maybe. Now, if I try to do the intersection right now, second trace 5, enter, 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 it's not going to work. Okay. Why? Well, because the intersection points, the x coordinate of the intersection point needs to be between your x minimum and your x maximum. Okay. If it's off camera, if your intersection point is off camera and it just because it's above or below the screen, that's fine. It'll still find it. But if it's off to the left or the right, it won't find it. So we need to go to window and push out the x minimum. Okay, because our x minimum right now is -10. We got to push that out further to where that intersection point is. I don't know, maybe -12. Is that enough? Probably not. Nope. Okay, well, what about like -15? Ooh, nope. All right, I'm going to just go for the gold. -20. I'm taking the gloves off. Aha, there it is. There she blows. Okay, so second trace 5, enter, 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 and -17.27 repeated. Okay, -17 and 27.99. So that would, sometimes you have to do that, and sometimes there's other things that are tricky about it, like if you're graphing reciprocal functions. But we're not going to explore that in this video. Anyway, but that is how you do it. So practice it, because this is super, super, super useful in algebra classes. And I'll talk to you later.